Well, hello. This lesson is titled Surface Area of Prisms. So let's first go over a couple definitions here, or a few definitions. We have a prism. What is a prism? A prism is a solid, so it's going to be a three-dimensional object, whose bases are congruent and parallel polygons. So that's going to be key right there. They're congruent and they're parallel polygons. And the lateral faces are going to be parallelograms. Well, what are lateral faces? And what are the bases? Now, these next few definitions, there's multiple definitions for each, but we're going to be speaking specifically in terms of prisms. So the bases of prisms are the two congruent and parallel polygons that are faces. Again, congruent and parallel polygons. The lateral faces, what's key here is that they are parallelograms, parallelogram faces on a solid that are not the bases. So the lateral faces are not the bases. And then we have the altitude. Now the altitude, again, of a prism is the perpendicular segment. So there goes the key word there. The perpendicular segment that joins the planes of bases. And lastly, we have, excuse me, surface area. And this is where we're going to be focusing mostly today, is surface area. It's the sum of the areas of the lateral faces and the bases. So what happens when you find all the areas of all the faces on that solid, on that prism? So that's what we're going to be dealing with. So let's get to it. So here is a picture, a couple pictures of prisms. Now we have here a right prism. A right prism is a prism whose bases are directly above each other. Notice it's perpendicular. So we have our right angle here, meaning one base, that hexagon, up top is directly above the hexagon on bottom. That would be a right prism. And it has the different labeling here. So again, this is your lateral face. So this front is one of the lateral faces. And notice if it's a right prism, not only is the lateral face a parallelogram, but it's specifically a rectangle. And then we have here the oblique prism. Now, the oblique prism is when the bases, so we have this hexagon up top. Notice it is not directly above the bottom hexagon down here. So it's kind of shifted over. But they still are parallel to each other. That's what we call oblique. And the thing to notice here is that the lateral faces on this one are not rectangles, but they are parallelograms. Okay? So all prisms have parallelograms as lateral faces. It's just our right prism has the special parallelogram, a rectangle, as its lateral face. Now we're going to be dealing mostly, almost predominantly, with right prisms for this lesson. So let's take a look at this. Now first, we're going to come up with a formula for surface area. But first, let's actually come up with lateral area. Let's come up with that first. Now, how do you derive the formula for the lateral area of a prism? Well, if you were to take this prism right here, if we were to fold this thing out, so here we have this, what we call a triangular prism. By the way, you name a prism by the shape of its base. So here we have two bases that are triangles, so it's a triangular prism. Well, if we were to fold that out and look at, and have here what we call a net drawing, we'd see that the lateral faces, again, as I said above, are rectangles. So we have these three rectangles here. Now, if we wanted to find the area of those three rectangles, remember that the area of a rectangle is base times height. So in this case, we'll call this rectangle 1, rectangle 2, rectangle 3. Now notice all of them have the same height, h. They just have different lengths of bases. So the area of the first one is a times h. The area of the second one is b times h. And the area of the third one is c times h. So if we wanted to find the entire lateral area, and we're going to use a capital L for lateral area, we would have AH plus BH plus CH. Now, we're trying to come up with a formula here for any prism, not just this triangular prism. So the question is there anything we could do to find anything that's going to be consistent in here? So we can notice all three of these areas have the same exact height. So we can factor out that h right there, leaving us with a plus b plus c on the inside of this parentheses. When we look back to our original prism that's not folded out, notice a plus b plus c. That's actually the perimeter of the base. So our formula now is the lateral area is going to be our perimeter times the height. So this is going to be the formula for the lateral area of a prism. It's the perimeter of the base times the height of the prism. And again, know what variables stand for. Formulas are no good if you don't know what variables stand for. That P is the perimeter of the base, height of the prism. So now let's put that into play here. So again, let's write that out. Lateral area is perimeter times height. So find the lateral area of the prism round to the nearest tenth. So the first thing you want to do is establish which one is the base. Always do that with the prism, is what is the shape of the base. Now please, you must remember that base does not automatically mean bottom when you're dealing with figures. So the base right here, it's tempting to say that is a rectangle on the bottom, which with the way this is drawn, yes, the rectangle is on the bottom, but that's not the base. The base is, remember, the bases are the two polygons that are parallel to each other and are congruent. So here we have a triangle and we have this triangle that are congruent and parallel to each other. Those are our bases. Even though they're not on bottom and on top, these are still going to be our bases. So here we go. Now we need to come up with the lateral area. So first we need to find the perimeter of this triangle. So keep in mind, perimeter is add up all the sides, but here we're missing our third side here. But again, it is a right triangle, and we know two sides. Whenever you know two sides of a right triangle, you can always find the third by doing the Pythagorean theorem. So in this case, we have leg squared plus leg squared is equal to our hypotenuse squared. We'll call it x. So let's do some calculations here. So you have 25 plus 36 gives us 61 is equal to x squared. And don't ever forget to root it. We don't want x squared, we want x. So the square root of 61, and again we're going to go to the nearest tenth here, is 7.8. So now we know that this here is 7.8. Which means our perimeter is equal to 6 plus 5 plus 7.8, which gives us 18.8. And our height, and remember, h in our formula is the height of the prism. Now this is also tricky because, again, we think height means straight up and down. But when you're talking about prisms, you have to consider where the bases are, because the height of the prism is the distance from one base to the other. So in this case, it's going to be from triangle to triangle. This is going to be our height right here. So in this case, it's 7. So when we go to our lateral area formula, we have perimeter, 18.8, times our height. So 18.8 times 7 gives us 131.6. And we are talking about area. And so when you label your units, it's going to be your area squared. Don't forget, it's area squared, or unit squared, sorry. Alright, let's go to another example here. Here, you don't have a picture, you just have it in words. The length of each side of the base of a regular octagonal prism, right there, that's going to be key, is 6 inches and the height is 11 inches. So we have a regular octagonal prism, so we know that each side is 8. And don't forget that regular means it is equilateral. So it's an equilateral octagon. And it says that each side of that base is going to be 6. Which means our perimeter is going to be 6 inches times 8 sides, because it's an octagon. Which gives us 48. And it gives us the height, so there's actually not a lot of calculations to be done here. So we have everything pretty much that we need. So our lateral area is going to be 48 times 11, which is equal to 528. And in this case, that's going to be inches squared. So here this is nice because we're given the amount of sides, the length of each side, and the height, which enables us to find which enables us to find the entire lateral area without having to use any other calculations. Okay, well, just a recap, by the way. If you had to find, let's recap different areas of polygons, because again, the shape of the base is going to change from one problem to the next, so you still need to find the area, know the area formula for each. Because what's going to happen is we're going to find the surface area. Now the surface area is the lateral area plus the shapes, plus the areas of the two bases. So a triangle, a generic triangle, is 1/2 base times height. An equilateral triangle is √3/4 times your side length squared. A square is a side length squared. It's pretty bad. A rectangle is base times height. A regular hexagon is 3√3/2 times your side length squared. And lastly, we have the regular polygon. Now again, polygon meaning any shape with 3 or more sides. So again, a regular polygon, so an equilateral polygon, is going to be 1/2 apothem times perimeter. If we remember how to do those. Now please remember, a polygon, regular polygon, so a hexagon is a polygon. So you technically can use this formula to find the area of a regular hexagon. You just wouldn't want to if you already know side length, because we have a much easier formula for that. So we're going to use regular polygon formula for mainly pentagons and octagons. But you can use it for any regular polygon. There's one I actually left off here. I forgot, so let's throw that on there. A trapezoid, just to recall, the area of that is 1/2 times the height times base 1 plus base 2. So we want to remember the area of a trapezoid as well. Alright. So let's talk about surface area of a prism. Now surface area means all of the faces. So we'll use a capital S for surface area. Now that's going to be your lateral area plus the two bases. Now we do have a little bit more specific. Now we know that the lateral area is perimeter times height. And then we have plus 2b. Now we don't have capital B, which is base area, area of the base. We don't have that written as a specific formula because the shape of the base will and can change from one problem to the next. So here, find the surface area of the rectangular prism. Now, if I'm ever dealing with a rectangular prism, I always use the bottom as the base, because they're all rectangles. So it technically doesn't matter what side you use as the bases. So I just default to the bottom. So in this case, again, we're asked to find the surface area. And notice for surface area you have 1, 2, 3 variables to find. So the first is going to be perimeter. So the perimeter of this base, 9 plus 4 plus 9 plus 4. So this gives us 26. You have the height of the prism, which is in this case 6. And then we have the base area. Okay. Now you have base area. And since it's a rectangle, it's just going to be length times width. So 9 times 4, which is 36. And now you have everything that you need to throw into your surface area formula. Surface area is equal to perimeter times height plus twice the base area. So when you do those calculations, you end up with 228. In this case, again, we're still dealing with area, so that'd be feet squared. So that's how you find the surface area of this rectangular prism. Again, they name the prism by the shape of its base. Here, we'll just do 2 more for prisms here. Find the surface area of the triangular prism. Again, surface area, perimeter times height, plus twice the base area. So we need to find perimeter, we need to find height, we need to find base area. So the first thing is, it's a triangular prism, so we know we're using this triangle as the shape of its base. Well, we need to find our third side. So you can use a Pythagorean theorem, yes, or this is a right isosceles triangle, which means this angle here is 45. So we have a 45, 45, 90 triangle where if you know the legs, you just times it by root 2 to find the hypotenuse. Or, again, you can do the Pythagorean theorem, that's fine. But in this case, we're just going to go ahead and say this is 12 leg plus the other leg plus the hypotenuse, which gives us 40.97. So we got 40.97. But if we're rounding to the nearest tenth, that 7 bumps that 9 up to a 10, which moves that 0 up to a 1. So we have 41. That would be our perimeter. And again, the height of the prism is from base to base. So in this case, triangle to triangle. Again, height does not automatically mean straight up and down. So we have 8 for our height. And lastly, we have the base area. And the shape of the base is a triangle, so we're going to use 1/2 base times height. Now, if it's a right triangle, remember the legs that make the right angle play the role of your base and the height. So in this case, 12 by 12. So 1/2 times 12, which gives us 72. And now you have enough to throw into your surface area formula. You have perimeter, 41, times the height, which is 8, plus twice your base area. And that gives us a total of 472. That'd be millimeters squared. Alright, let's do one more. Again, we have a triangular prism. Find the surface area of the triangular prism. So we need perimeter, we need height, we need perimeter, we need height, and we need base area. Well, the perimeter, you're given here 8 and you're given 10. So the question is, what's this other side? Well, it does give us this 6 in the back. And if you didn't, even if they didn't give us that 6, we could do the Pythagorean theorem, or we could realize that this is a Pythagorean triple, 6, 8, 10, which reduces to a 3, 4, 5 triangle. So our perimeter now is 6 plus 8 plus 10, which gives us 24. We have our height, again, triangle to triangle, base to base, 5. And lastly, we have our base area. As a triangle, it's 1/2 base times height. And again, if it's a right triangle, the legs that make the right angle are your base and your height for the triangle, which gives us 24. So that's enough. We can go to surface area is equal to perimeter times height. Whoa, that was supposed to be a 5. Perimeter times height plus twice the base area. And that total is 168. That would be inches squared. So that's how you find surface area. Again, find the lateral, perimeter times height, and add the two areas of the bases, and that will give you surface area. There you go.